Wait, so how are you in the Zoom meeting exactly? Like why do you have to go to the Zoom website right now? What are you trying to do?
I'm trying to get my camera to work. I'm
Oh,
not sure. Yeah, I don't know why. I don't know. This just stays on
okay.
once I launch the meeting or once I start the meeting. Um, oh, I did not mean to do that. But what I'm trying to do is it won't let me do video. It tells me that it's unable to detect the camera
I don't know if it's a problem with your computer or maybe it's a problem with the program.
with Zoom, you think?
I have no idea.
I think
I
you
know.
should like reset the computer. Maybe that could help you.
Do what?
Like reset the computer.
Oh yeah. Um, yeah, I have honestly, no, I don't want to close that. No idea. So when I normally go to Zoom, I do I go to schedule meeting and then I go to my meetings and then see I have all these, oh, it's in progress. And see, this is how I can get to my different classes. So when I start them, this is what happens. And it always tells me kind of the same with you guys, like, do you want to join with computer audio? And I always click yes, but I don't know why all of a sudden it just stopped showing my video. It seems like it wants to. It just, see when I click on it, it just tells me it's unable to detect a camera. And I was telling the other guys, like the little button at the top, like whether I turn my camera on or off, it doesn't say on or off. It just, you slide it one way or the other. And no matter what I do, oh, I can see it now. It's open, it's on, and it still just tells you.
Are you using a laptop or are
Yeah,
you using
laptop.
laptop? Do you have any other computer that maybe you think could work? I
Oh,
honestly think it's the computer. I don't
it's
see that it's the program's problem, because if it is the program's problem, I don't think we would be able to maneuver everything that you're doing right now.
yeah, right. I think it's just flat out, it keeps saying it can't detect it. So it's like, to me, yeah, I agree. Obviously that's the problem. Right now, no, I don't have another computer. Um, so there's that. So if we can get today, I mean, I think I can still write because you can still see my screen, correct?
Oh no, yeah, we can. We
Okay,
can. It's
so
just it's
yeah,
just
it's just
you.
going to be a nuisance that you can't see me. That, that's kind of I'm kind of assuming you want to see me. Y'all don't have to answer that. I can see your faces, so that for me is, I guess, good enough. So this week, Cody, I saw your email. I don't know why I'm having such problems. I think last week because I went over, it's just really giving me a hard time about uploading those videos from last week. I promise I will get that and I'll get that done. I'm going to work on it today. Now I'm calling into question whether it's just my laptop that's having problems with everything. Okay, so or as my dad would say, it's not the equipment, it's the operator, right? So it might be me too. um, but I promise you I will get that figured out. Okay. Um, today we start with null hypothesis testing, and a lot of it is just words and understanding what we're going to do. So there's not too much calculations yet. When we start doing the t-test, that's when we bring back in the math. So to continue on from last week, where we started talking about the t-distribution, just in case for anybody who's here that didn't get to see that last week, the t-distribution is similar in a way to the normal distribution or the normal table, in that it, becomes a normal distribution when you have a really big sample. The t distribution is based on sample size. The really smart guy from Guinness Beers, Gossett, is the person who figured this out, that we have to have a type of distribution that is based on various sample sizes. Okay, and so we looked at that t table where we found different numbers. It's right down here. It kind of looks like that Z table that we were looking at. Last week, we talked about a little bit, I'm going to explain it more. We talked about a two-tailed test, and we talked about a one-tailed test. We talked about how in social sciences, we set our alpha at a 0.05. Okay. This is, it's convention. It's a good rule of thumb to go by. Okay. You can obviously always go smaller, which is making your significance stricter or stronger, if you, maybe that's a better word. And like medical, when they're testing drugs and medications, they use a 0.01. And so what that means is they're looking at the extreme 1% of, say, the distribution. And to tie that back to just make a little bit more sense, remember when we were looking at IQ and how rare and how uncommon Einstein was, and how far out in the tails he is. Okay, so we're going to be bringing that with us when we're looking at extreme values that are way out in the tail. Okay, we know that it's not a very high probability that you're going to get something out in those tails, or it's not a high probability that a person would be out in those tails. Okay, so this is what we're going to be bringing with us. All right, so today's the day, hopefully, that it kind of all comes together, that we tie it together, and we now understand what in the world, why I've been going off and talking about Einstein so much, and what in the world has to do with this probability and these extreme scores. Okay, so hang with me a little bit. Let's get through some of the definitions. Okay, so this NHST up here, okay, stands for null hypothesis significance testing. Okay, we can say that 5 times fast, right? Null hypothesis significance testing. So null hypothesis testing, you guys probably had a little bit of this, or may have seen some of this in biology class. If you've taken any math statistics classes, you might have gone over this. So null hypothesis significance testing, I'm just going to say NHST, is the process that produces probabilities that are accurate when the null hypothesis is true. Okay. So now let's define null hypothesis. Okay. The null hypothesis, which we mark off, I'm going to use like green or something, which we mark off with this HO, okay, or H0 technically, okay. Null hypothesis, or H0, is the hypothesis about a population or the relationship among populations. That's the definition straight from the book. I don't really like that definition because it doesn't really tell us anything, okay? It just is saying that we're going to make a hypothesis about a population. But I think the important thing to know that's more important about the null hypothesis is that it says there is going to be no difference among the means. I can say it another way. The null hypothesis says there will be no difference between the groups that you're testing. Okay, so when we sit down and we want to say, okay, people eat more potato chips when they're watching the Super Bowl compared to news, the null hypothesis is going to say, don't even waste your time. Don't do that dumb study. Nobody cares about potato chips because there's not going to be a difference anyways. There's going to be no difference among the means. Okay, null here, null means zero. Okay, right? Null or nothing. I like to, right here in my head, pops in the movie Three Amigos. I don't know if y'all seen it. It's kind of old now, but it's a classic. So they're sitting there talking to somebody and he says, do you know what nada means? He's like, in all of those movies that you did in Mexico, did you learn what nada means? And then Chevy Chase goes, I think it's a light chicken gravy, which it's not, right? But nada, and then the guy gets real mad and he goes, no, it means zero, zip, zilch, right? All these different words for zero or nada, right? So null means zero, zip, zilch, nada. And I like to kind of make that association for you guys because we have a little zero right here, right? Reminding you zero. There's going to be no difference, okay? No difference among the means. All right. The alternative hypothesis, sometimes people call it the research hypothesis, okay? But in this instance, they call it the alternative hypothesis, and it's signified by H1, okay, H1. And why it's a 1 really is, I mean, you can kind of think of it like, oh, it's the opposite of H0, right? 0 meaning nothing, and 1, you know, there is something. But really, the real reason why it's H1 is in complicated research, researchers can have multiple hypotheses. Okay, so then they would just number all of their hypotheses. They could have H1, H2, H3, H4. Okay, so that's really why it's labeled H1. Don't worry about it. In our class, we will only go with just one hypothesis. Okay, we don't need to get too complex in this class. So H1, the alternative hypothesis, again, I'm very used to calling it the research hypothesis, and I kind of like research hypothesis more because it states what it is, right? Alternative just sounds weird. Research hypothesis, it's what the researcher expects to find. It's what they're looking for. It's the purpose of their study. Okay, so here the definition, and again, I just took these definitions from the book, and that's why they're, I don't know, in my opinion, maybe a little odd or a little off. Okay, but how the author defines it is the hypothesis about a population parameter that is accepted if the null hypothesis is rejected. Okay. I'm going to erase some of my scribble here just so it doesn't get in our way. Okay, so let's break that down. So it says it's the hypothesis about a population or about population parameters. I realize now that doesn't even make sense. A population parameters, excuse the typo, that is accepted if the null hypothesis is rejected. Okay. Our goal in NHST when we're testing significance is to attempt to reject the null hypothesis. Okay. I realize now I didn't go over these little things. This is how you write it symbolically. Okay. That you can, we'll get into that a little bit later where we start writing out all of our testing and our hypotheses and whether we determine it's significant or not. So you can write this symbolically. So what this is saying here is the alternative hypothesis is saying that the mean of this population will not equal the mean of this population. Okay, so it's the opposite. It states that there will be a difference, right? Of course, the researcher thinks there's going to be a difference, or else they're not going to do the research. Okay, the people that were like Pfizer and Moderna, they believed that their vaccine will cause a difference in your ability or lack of ability to contract the coronavirus. Okay, so now we know the null hypothesis is out there. He's sort of theoretical. He's philosophical. He's out there hanging over our heads saying, nope, don't do it, Pfizer. You're not going to find a difference. You're going to waste all these millions of dollars in time and energy, and this vaccine will not work. Okay, but the researchers believed in themselves and they said, nope, we think it's going to work and we're going to go for it. We state there will be a difference. Okay, so then the big test comes down, right? What are they going to do? And they start gathering their data and they start getting their numbers, and we will learn, you know, kind of, sort of how they would do that. Okay, so any questions right now just about the null hypothesis and the alternative hypothesis? No, Natalia's good. Okay.
Different, so you see population, it can be any type of population, so the null hypothesis shows no difference in like the populations in what aspect, like numerically, in what sense?
Yeah, good question. And it would honestly be anything that you're testing. So, but for you always have to, in some way, add a numerical value to something, to your variable, so that you could ultimately run the numbers. And I'm not sure if that's exactly what you were asking, but you know, yeah, you like to say whether, you know, there's truly a difference between fingerprints, or like I said with the potato chips, or you know, will this exercise program really cause somebody to lose weight? So does that answer your question? Or no? Okay.
But I'm still confused. I mean, I probably shouldn't overthink it, but it's just like I'm trying to make sense of it, as in like where's the difference? Or like, for example, in alternative hypothesis, what makes them different? Like, or what makes them not different for a null hypothesis?
Okay,
mean,
are you talking about right here? Kind of,
yeah.
sort of? Okay, so what we're gonna do is we're gonna have to get the mean of one group
Okay.
and then the mean of another group.
Okay.
Well, that would be two sample testing. One sample testing, let's say we know the IQ is 100, right? The average IQ is 100. Maybe somebody comes up with something and they say, oh, we've got these little Einstein videos, and we think that it's going to improve kids' IQs. And we say, okay, we'll go for it, right? Let's see what you got, right? So these people start enroll kids and show them or teach them these little Einstein videos or whatever it is, and then later test them. And then we would compare to see if that group of kids, if their IQs truly are different
Mm-hmm.
or not different from the
Okay.
100.
Okay.
Does
Yeah,
that
yeah.
that helped? Okay. Okay, so that's what we're going to be doing. These, again, the symbols, you know, we don't need to worry too much about them, because this can all get very complex also. So this is simplified for this class. And Natalia, maybe honestly, that's where your brain is, and you're just kind of like, this just doesn't make sense. But so this, you know, say the population mean we know is 100. And the researchers assume that it will not equal their sample mean, okay? Or the kids that watch the videos, okay, would have a higher IQ.
Oh, yeah. No, it's
Okay.
just that like my brain was like, well, it's like if you have two different populations, like there has to be some kind of difference between them, you know?
Right.
So
Yes.
that's why I got a little bit confused in the null hypothesis in the part where it says there will be no difference among the.
Among the means. Yeah. So, and again, this is like, we're assuming that there's going to be some sort of treatment applied. There's going to be some sort of experimentation that happens. So at that point, you know, the researcher would assume there would be a difference, but Mr. Negative Null Hypothesis Pants over here is saying, no, there's not going to be a difference.
Okay.
I realize I didn't do this. So why on earth do we do this? Why are we even going to worry ourselves about the null hypothesis? Like Natalia's saying, why, if they're from the same population, why won't there be differences, or you know, why is it even worrying about that? So, you know, and I don't know who came up with this stuff, but it makes sense. So what let's think about this. I brought up about the fingerprints on our hands, right? Our fingerprints. And it's convention, or it's believed, it's widely accepted that no two people have the same fingerprints. And it's so widely accepted that it's used in police cases, right? To lock people away for years. That's how accepted that this statement is. However, have we ever disproved that statement? Like, we know for sure we haven't found any evidence that tells us that, right? We've never found two people that have the same fingerprints. But can we for certain, for 100% say that we know that statement, or that the alternative of that, is not true? That maybe, like when Napoleon was around, I don't think they were doing fingerprints back when Napoleon was around, that maybe Napoleon has fingerprints of, say, me, or someone that's alive right now, or that in 2,000 years we wouldn't have fingerprints of someone that's alive right now. We don't know that. And so null hypothesis testing, it is theoretical, but what we try to do is we don't try to only say I'm right. We also try to say the negative is false. Or if you're in an argument with somebody and you're just trying to argue, I'm right, I'm right, I'm right. It's a little bit easier to win that argument if you can truly come out and tell the other person, this is where you are wrong. Does that help with this? Okay. So null hypothesis testing, we're trying to prove it wrong. We're not only trying to say we're right, like with the alternative hypothesis. We're not trying to say, oh, look, I got it, I'm right. We're like, it's more robust than that. It's a stronger argument than that when we try and say, you know what, we're rejecting this argument. Not only am I right, but the null hypothesis is wrong. Okay. Okay, I'm going to move on from that unless somebody has a question. No? Okay. So let's go through some. This is, again, a lot of definitions here. I think I told you guys, right? There's a lot of words today. Okay. So here are all these definitions. The first one, we're going to be looking at alpha level, our alphas. And that is the probability of a type 1 error. And we're going to get into the errors in just a little bit. Okay, so we can just, right now, we can just write this down. I'll show you right here. Our alpha is right here. So it says alpha level for a two-tailed test, okay? And we're always going to be picking our alpha of 0.05, okay? Because that's just what we do in social sciences. All right, so the alpha is the probability of committing or having a type 1 error. Okay, significance level, right? The significance level is the probability that is chosen as the criterion or criteria for rejecting the null hypothesis. Okay. I'm going to go back to this real quick. So what we do, again, in social sciences is we pick an alpha of 0.05. That's going to be our criteria, okay, for rejecting the null hypothesis. Remember, we not only want to say I'm right, but we also want to reject the null. Okay, we want to reject the null. If we get a number that allows us to do that, we're going to say that we have found statistical significance, or we have a statistically significant difference between our groups or between our means. Okay, so the difference is so large that chance is not plausible, that this didn't just happen because of the aligning of the stars. Okay, let's say the little Einstein example, that if they find that all these little kids now had an average of, say, you know, an IQ of 110, I don't know what the cutoff would be. It would depend on how big their sample is and all of that stuff. But let's say it bumped their average IQ up to 110. If that was just statistically significant, then we could say, you know, this result is so big that it didn't just happen by chance. It couldn't just be that all these little kids woke up that morning, ate their Wheaties, and went and took that IQ test, and they just rocked it. Okay, it's got to be because of that those videos that they watched. Okay. When we see that the Pfizer and the Moderna vaccines are, you know, preventing, you know, however, whatever the percentage of people from getting coronavirus, when they ran that through their statistics, they found that that significance was so big that it's not just by chance. It's not just by chance that the vaccine was working. There was really something in there, and those people are not getting the virus, okay? NS. This is just a womp womp when we do our statistics, okay? This is if it does not work out and we did not meet the criteria. We cannot with confidence say that it is not due to chance, okay? And I'll show you different examples of this, like in pictures and stuff, so I think it'll make a little bit more sense than just the words, okay? We will set up a rejection region, okay? We will set up a rejection region, which is going to be the area of the curve. Here it says a sampling distribution, but we'll just, it's a curve like we draw, okay, all the time. We're going to draw a little curve, and it's going to determine the area that corresponds to the test statistic that will lead to the rejection of the null hypothesis, okay? So I always think of the rejection region like in dating terms, you know, we never want to be in the friend zone, right? But I think the friend zone is a lot better than the rejection region, right? I mean, you don't want to fully be rejected. However, in statistics, we do, okay? We want to find our way into the rejection region, okay? Because when we're in the rejection region, then that means we are rejecting the null hypothesis, and that is good, okay?
Why do we keep rejecting the null hypothesis?
Remember, because he says there's not a difference.
Oh, okay.
And so we want to reject him and say, yes, there is.
Okay, yes.
Okay, yeah. Yeah, good question.
Also, I noticed that I don't think you put these slides in on Blackboard.
I have not, and I will. Yeah,
Okay.
I will. There's going to be, you're going to see that this is going to run out real quick because we're just going to be drawing kind of examples. And I know there's more stuff I want to put on here. Okay.
Okay.
I think we're just going to kind of hammer this home, and then we'll start t-tests and really doing all of those number crunching like next week. Okay. Is that okay?
Yeah, that's fine. No, I just wanted to make sure.
Yeah, I will do it. Thank you for reminding me. So the, okay, rejection region, the critical value, which sometimes, you know, I'm just going to make this little correction right here. Sometimes we call it, or not sometimes, a lot, okay, we'll call it the CV, okay, or the CVs actually. I'm going to put a little S down there, okay. So the CVs are our critical values. And this is just going to be a number that's going to mark off where the rejection region is. Okay, I know this is a lot to take in right now. I think it's going to be a little bit better when we start seeing some pictures. Okay,